Purpose of this lesson is to enable you to sketch graphs of trigonometric functions, using transformations. We'll start by looking at our basic sine and our basic cosine graph. They're pretty much the same graph, just that in the sine graph we start at 0 and go to a maximum value. In a cosine graph we start at the maximum value and go down. So remember what sine and cosine graphs look like. For these two graphs, we can look at their amplitude, period, and average value. So the amplitude of both of these graphs is 1, which is the distance from the maximum to the average value. That's my amplitude. The way I can calculate it if I'm not sure is I can find the max, take away the min, and divide by 2. So I've got a maximum minus 1, maximum of 1, minimum of minus 1. If I substitute those values in, I'll get my 1. Okay, in terms of the period, sometimes referred to as t, is the distance between two corresponding points on the graph. So this distance here is my period. Period of both of these is 2 pi. And you'll get that just by inspecting the graph. The average value is where we have the symmetry. So we can see for cosine, I have symmetry at y equals 0. And the way I can find this is by finding the average of the maximum and the minimum values. So my maximum is 1, my minimum is minus 1, divided by 2, I'll get an average value of 0. Those three values, amplitude, period, and average value, are going to be what determines these three letters in our cosine or sine graph. There's a relationship between those numbers and the amplitude, period, and average value of a graph. So I've got 8 different functions here where we've done something to the sine graph. We've either multiplied it by a number or we've multiplied the angle by a number. I want you to go through and find the amplitude, period, and average value for each of these, and then have a look at the solutions. Here's a solution for the first 4, and then also the solutions for the last 4. The reason why we're doing this is because I'm interested in knowing what is going to make either the amplitude not be 1, the period not be 2 pi, or the average value not be 0. What numbers in the equations are going to be changing those values? So in terms of the amplitude, I can see that these first 2 have had a change of amplitude. And we can see what's happened, what's caused that is the number out the front. So that 2 out the front has made the amplitude 2. That 0.5 out the front of the cosine has made the amplitude 0.5. Okay, so what we know is that the A value, talking about the number in front of the sine or cosine, the A value is the amplitude. If I look through the other options, they've all got amplitudes of 1 because they don't have any number in front of the sine or cosine. Except these last 2, where we've got either a -1 or a -2 in front of the function. What the negative value has done is my normal sine graph starts at 0 and goes up. It's changed that, it's flipped it vertically, and instead it starts at 0 and goes down. Similarly with the second option, with this -2, cosine normally starts at 1 and goes down. What the -2's done is said, well, we're going to start at not -1, so it'll start at our minimum value, which is now -2 because of that amplitude change. So I'm starting at my minimum value and going up. Whereas a normal cosine graph, if that was a +2, would start at 2 and go down. So from these two, what's important to note is that if we have a negative A value, that negative sign starts at 0 and goes down, and that negative cosine starts at the minimum and goes up. So compare that to the sine and the cosine that we have at the top of the page. Now focusing on what makes this period change from 2 pi to something else. Well, these first two, the period is 2 pi, that's fine. These next two, the period is pi or 4 pi, and in all the other ones, our period is 2 pi. So when I look at these two equations, I see that there's a 2 here, and that there's a 0.5 here. So by having a b value, so when I talk about b value, I'm talking about this number that's multiplied by the x in both of these equations. The b value has changed the period. So I can write that. B value changes period. Okay, but there's a 2 and my period is pi. There's a 0.5 and my period is 4 pi. I need to know what the relationship between those two numbers is. Okay, the relationship is that the period is going to be 2 pi divided by whatever that b value is. We can test it on the first one. Period 2 pi divided by 2 gives me pi. Looks good. Test it on the second one. Period is 2 pi divided by 0.5, which gives me 4 pi. Okay, so this is one formula that you'll need to memorize. Remembering that a bigger b value means this thing's going faster and faster, which means the period will be smaller, which is why we're dividing by b. The only remaining thing to investigate is the average value. So what's going to change my average value from being 0 to something else? First two are 0, these two are 0. Oop. In the middle, I've got 2 where the average value has changed. Everything else has remained constant. Average value has changed. If I look at these two numbers, hopefully I can see some connection between my average value, where I have my symmetry of 1, and the number that's added to the end of the sine function. Similarly here, here's my average value of -1 and the number that's added at the end. If we look at our two equations, this is talking about a d value. Okay, so I know that the d value is the average value. So what we're going to do is use this knowledge that we've found in the right-hand column and use it to graph trigonometric functions without having to use a graphics calculator or Desmos or any technology. So I'll turn over the page and have a go at doing just that. So sketching these graphs, there's a few little pointers here for us if we get really stuck, but let's just have a go and see how we go. So I'm trying to sketch this function over this domain, so I know that I need it from -2 pi to 2 pi. That's what it's telling me about the x-coordinates. And I can look at this equation and see that it lines up with a sine bx plus d. So I can identify that a equals 3, which means that my amplitude is 3. I can identify that b equals 2, which means that my period is 2 pi over b. Remember that rule? 2 pi divided by 2, or a period of pi. And I can identify that d equals 1, which means my average value is 1. I'm going to go ahead and mark as much of this information on the graph as I can. So I know the average value is 1, which means I need the point 1 here. If I want, I can draw a little dotted line just to know that that's where there's going to be symmetry. My amplitude is 3, so that means it's not going to get bigger than 4. And if I go down 3, it's not going to get smaller than -2. So I've used these two pieces of information. I've used the amplitude and I've used the average value. Now to use the period, I know that I need to go from 0 to pi. I need to do one period. So if you look at your original sine graph, it does basically 5 things. Starts at 0, goes to the maximum, goes to the average value, goes to the minimum, and goes back to the average value. So when I want to draw my sine graph, I'm going to need to separate this into 1, 2, 3, 4 sections for those 5 points. So from 0 to pi, I'm going to divide this in half, and then divide it in half again, and then find out what's in between these two, 3/4. So now I can go ahead and draw my sine graph. It's a positive sine graph, so I know it starts at the average value, goes up to the maximum value, back to the average value, down to the minimum, and back to the average value. So this will be my first cycle of my sine graph. From here, I'm going to need to extend it in the negative direction, and I really want to get up to 2 pi, and I can't really get there, but negative 2 pi. I should have used my graph better. So go ahead, put all those points in, connect it together, and write the equation of the line. If you get stuck trying to figure out what these points are, just grab pi, press enter on your calculator, and add pi on 4, and just keep pressing enter, and it'll keep giving you those points. Yeah, so that's what our graph looks like. If you want to find some of these interesting points, like maybe you're interested in what that x-axis intercept is, you can put 3 sine 2x plus 1 equals 0 and solve that. Okay, remember x-axis intercepts occur when y equals 0. Okay, I'll move on to another example just so we make sure you guys can do this. This one is a cosine graph. It's a positive cosine graph. We should be able to identify these things pretty easy. A equals 2. So my amplitude is 2. A little bit harder is trying to find the b value. People typically think the b value is 2. X over 2 really means a half times x. So my b value is a half, and therefore my period will be 2 pi on b, or 2 pi on a half. Okay, I'll end up with a period of 4 pi. And finally, my d value of 3 means that my average value is 3. So I can go ahead and try and graph this as well. I'll look at my domain. It only wants from 0 to 4 pi, which is good. Amplitude of 2, average value of 3. Again, the grid's probably not the best for the graph, but my average value of 3, and I have an amplitude of 2, so I need to go down 2 to the minimum and up 2 to the maximum of 5. So I'm imagining my average value, my maximum, and my minimum. Do those lines in pencil so that you can erase them later. And now I just need to find a way to put 4 pi on here. Maybe I should just go up in 3s. Pi, 2 pi, 3 pi, and 4 pi. Okay, and again, I've divided this into 1, 2, 3, divided the period of 4 pi into 4 sections, so I can show what my cosine graph's doing. Positive cosine graph starts at the maximum, goes down to the average value, goes to the minimum value, back to the average value, and up to the maximum value. Now that I've got that drawn, I can erase my guidelines and go ahead and draw what this cosine graph looks like. Label the axes and write the equation of the graph beside it. So down in the bottom corner of the page are some questions for you to have a go at for graphing these functions.